So I'm back at this right now. Basically, we have got a few survey evidence that is not really fitting the plan. So I'm going to just draw little circles at locations where we found evidence. So that's a lot corner. We did not find anything at these lot corners. We did not find anything at this beginning of curve. We found a bent pin here at end of curve or beginning curve, depending on which way you go. We found one over here, which is the rear lot corner. We found one here. When I say here, I'm just drawing the circles at the calculated coordinate, but this is actually where we found the pin. So for example, this one, right now we have about 11 cents. Okay, we did not find anything there. So we got 1, 2, 3, 4, 5, 6, 7. These two, I can't find any legal plans that show two pins that are supposed to be 10 cents apart. So something, I don't know what happened here. Somebody planted two iron posts. Okay, so we got those two, and then we have another one here. So right now I think I mentioned our survey is based, the rotation of our survey is based off of this pin and the eye hole on this pin. But our survey is actually fixed on this pin. So you can see the pin is right at the lot corner. So now I need to basically calculate the boundaries of this lot right here. Now here in Alberta, the evidence that you find in the ground, in the field, it governs the boundaries. So even though these are bent pins and they don't really fit the plan, I have to use them. Okay, the evidence governs. Now I'm going to try to do my best, so I'm trying to recreate the purpose of the survey so that the property lines all work out. So to start with, I'm going to establish the property corner, this property corner which we did not find any pin. So we have an iron post here, okay, and then going along there we have another one here. So what I'm going to do is use this point number 15 and point number 14 to proportion these lot corners, this lot corner and this lot corner, that BC, and then basically that end of curve is going to be right where that eye hole is. Right now, between this eye hole and the end of curve, which is that point, I've got about 11 cents. So I'm essentially going to proportion this 11 cents. Okay, so this is how I'm going to do that. Right now I've got this, which is a block, but I have my original line work right here, which is individual entities. So I'm going to select that arc, this lot corner, this lot corner, this lot corner, and this arc. Okay, and I'm going to again make a block out of it. So Control Shift C from this base point, and I'm going to go back here and go Control Shift V right on that found eye. Okay, right now the other one, I'm just going to grab it and move it out of the way because I'm not using that. I'm just dealing with these line works. So I'm going to scale this entity to fit between this pin and this pin right here, and for that I'm going to use the align command. So AL is align, select source object, okay, enter, specify first source point. So first source point here, specify first destination point is the same. So my source point and destination point for this point are the same. Now it says specify second source point. So second source point is going to be here, and now it says specify second destination point. I want the destination to be this eye hole. Okay, that's that. So I'm done. Now it's asking if I want to specify a third source point. third source point, and I said I'm just going to hit continue because I don't have another one. It's asking me if I want to scale object based on the alignment points. I'm going to hit yes. So you see just what happened, that it scaled this entity so that now it fits between the two pieces of evidence, and in doing so it actually adjusted everything in a uniform fashion. So it scaled and rotated this entity between this point and this point, and in doing so there was little adjustment done to these lot corners. Okay, now in Alberta, when it did that, if I'm going to explode this, so I'll just hit X for explode. So now I'm dealing with individual entities. So on the legal plan, that this is an arc that I've got selected. On the legal plan, which is right here, that radius is 245. But if I list this point right now, because I scaled that, the radius changed from 245 to 245.46, and I'm not allowed to do that. When it's reestablishing property lines, the radius has to stay the same. So I'm going to delete this line. Okay, I'm just going to turn on my adjacent plans layer, which is my property lines, and I'm going to draw an arc. A for arc. Start point will be this point, end point will be this point. Okay, radius is going to be 245, like it was right there. So radius 245. Boom. Okay, so I just drew that arc. Okay, and I have to do the same thing for this one. This one on the legal plan is the radius is 6.5 meters. Okay, so let's do A for arc, start point, E for end point, and radius is 6.5. Boom. Okay, and I'm going to delete this other one. Bang. All right, so that's that. Okay, now these lot corners, they probably don't go right to the arc because we changed it. So distance from there perpendicular is about 1 millimeter, so I'm not worried about that 1 mil. Okay, so right now we've got our lot corner pinned at this corner. We've got this portion drawn, so now I need to draw the north property line, which is from here to here, and it is an arc with a radius of 1,536 meters. Okay, so I have a pin over here and I have a pin over here. Both of them are bent, but I'm going to use the eye holes and I'm going to draw an arc at that radius. Okay, so again, A for arc. Let's find that pin right here. So eye hole, this is going to be a start point. E for end is going to be there, and radius is 1,536 meters. Boom. Now the direction matters. So right now the center of my arc is over here. Okay, and that's when you're dealing with the large arc, it's kind of sometimes it's hard to tell which way is the arc, but just looking at this legal plan, I can see that this arc, which is a major road, is going that way, and all these other lines are parallel to it. So this arc starts and ends here for AutoCAD's sake. So the center is over on this side, not on this side. Okay. All right, so that's done. Now the back property line, going back to the plan, the back property line from here to here is a straight line. I've got an azimuth of 157 degrees, 18 minutes, 22 seconds, and a distance of 13.64. Okay, and I have a bent pin here and a bent pin right there, so I'm going to just connect those two. So L for line from there to the eye hole right here. Okay, and if I list that line or look at it, it's 13.78, and the plan was 13.64. So so yeah, not very good again, but not much I can do with it. I think what I'm going to do is look at some other shots here. to establish this property line, okay? Because this property line is between the private owner and the city. There's a city road here, okay? So I mean, it is critical, but I mean, there is pieces of evidence there. They're both bent, but we're basically using our best judgment to define where that is. But the critical boundary, I would say, is over here. I have been able to pinpoint the one corner just by proportioning between those two pieces of evidence. The back, I don't have a pin. I have a fence post, okay? But my surveyor has a shot on the adjacent property. So if I just do a distance from here to that property line right now, it's 1.17. So I know that in our city, the minimum setback is supposed to be 1.2. Now that is a stucco shot. Stucco, when I say 1.2, that's to the foundation. We have a stucco shot. Stucco is usually 1 cent offset from foundation. So, you know, I'm at about 1.18, which puts me within an inch of being compliant. We have a foundation shot for our house. I'm gonna just do a quick distance here, and 1.32. So that's quite large, actually. Do we have anything back here? Yes, we do. We have a foundation shot right there, and that is 1.34. So seems like we got quite a bit of room here. Okay, so what am I gonna do here? What am I going to do? So what I have decided that I'm going to do is basically this is the plan, right? This is the plan calculations. I am going to move it from this lot corner, so M for move, from here to where I have calculated intersection of this line and this arc. Okay, so basically it's like we are using the plan angle to draw that property line. Okay, so I'm just going to draw a line from there to that intersection point. And again, I'm going to move my plan out of the way. Okay, so here essentially I have two, and you see that it moved a little bit basically, and look how close that is to that fence post right now. So the fence post fits within 4 centimeters to the property line. So I'm going to use this as my property line. The angle on this is 66 to 12, and the angle on the plan is 66 to 12. So essentially we're basically, we proportion this corner in, and then from here, this property line, I'm just using the assumed plan angle, okay, and distance, which is 33.8. Okay, now let's just try something. If I extend that line to this point, let's see what happens here. You see that this pin is off quite a bit, but you can see this is the top of the pin, this is the base of the pin, so the eye hole could actually be a little bit further. If we kept digging for this, probably the eye hole would be closer to being on the line. So I think I'm happy with this property line here. So I'm gonna delete this one. Okay, I'm gonna break this arc right there. Okay, so we got basically just double checking things, 245, and I don't really care about those two. If I were to basically calculate the property lines, I'd say I'm done. I'm just gonna get rid of these circles. There's 4 of them that I drew. Delete those. So what happened? Let's just redimension these. Select similar, delete. I'm gonna put my text dimension layer on as the current layer, and let's just do a couple dimensions. So foundation to property line 1.3, stucco to property line 1.19, so 1.2 basically to the property line, very close. Here in the back corner, foundation to property line 1.28. Yeah, think I'm happy with that. Now the next step would be to start drawing some stuff here. So let me just pause this. So in order to be able to draw the house, we have field notes here, which basically shows the house, dimensions of the house, going all the way around, and all the features. Basically, we got retaining walls, we've got steps, we've got fences around. Okay, so first of all, what I'm going to do in AutoCAD, I'm going to draw the house. So the foundation outline of the house using these dimensions. So I see 9.14 F. That means my field guy has measured the foundation to be 9.14 at this back. From here to here, this corner, I believe that is 11.59, then 3.05, 6.71, 6.11, and then 18.28 overall. Okay, so I'm just going to put this in my other screen and put my current layer on building, put on my ortho. You can do it also doing F8. I'm going to type in PL for property line, for polyline, start from anywhere. And you guys can't see these, but I can see the field notes on my other screen. So I'm going to just keep drawing. So 9.14, then go this way 11.59, then go this way 3.05, then 6.71, 6.11, and 18.28. Okay, so let's see how good we closed. So distance from end to the beginning, we have about 28 millimeters of distance, about 3 cents, which is not bad. Okay, so I'm going to turn off my ortho. I'm going to move it from any corner, basically, so I know that is probably the foundation corner right there. Okay, I'm going to rotate the house from here, so from there to the back, I am going to use the other survey point right there. Okay, so essentially this ST means stucco, that's a stucco shot, and this is a foundation shot. I'm just going to get rid of the dimensions here, delete. So essentially here, between this foundation corner, this is a coordinate that's surveyed by the total station, from foundation to foundation, we have 18.314 meters, and in the field it was measured at 18.28. That same distance is 18.28 with a tape measure. Okay, so I usually accept the survey points over tape measurements, so we're going to do that basically. So I'm just going, this is a polyline right now, so I'm going to hit X for explode. I'm going to move that line to that shot. I'm going to move this guy from there to the shot. Let's see if we have any shots over here. Oh yeah, we have, again, we have stucco and we have foundation. So move this line to that foundation, move this one to there. Let's see what we have at the other. So that's, what is that, center line, wood border. We have a stucco shot there. We have stucco shot there. We don't have a shot for this garage corner, which is not good, but that's okay. So why is that stucco shot? How far is that from the corner that I've got? About 7 cents, essentially. Okay, so here's what I'm going to do. Again, I like to use the shots. So I'm going to use this stucco to stucco. Okay. This dimension I know in the field was measured at 6.11. Here it is again. Oops. What did I do there? It was measured at 6.11. Okay. But really that's 20 feet. 20 feet is 6.096. So I'm going to make this, one end is at the foundation. The other end I don't have a shot, so I'm going to do LEN, and I'm going to make the total length 6.096. Okay, boom, do that. And so I'm going to accept that as being one corner. The other corner we have a stucco shot, so I'll show you what I'm going to do. I'm just going to actually delete that line for now. So I've got two stucco shots. Okay, and I think I said that stucco should be 2 cents offset, so offset 0.02. So I'm going to offset that line by 2 cents, get rid of that one. So essentially this line is offset 2 centimeters. Okay, and I need to shorten it by 2 cents as well. LEN delta negative 0.02. Okay, and then my other line will end at that corner. So basically this building line has been drawn using a foundation shot at the back and using a stucco shot by an offset of 2 centimeters each way. So this is what I was trying to demonstrate here, basically, is that we got a stucco shot. Stucco to foundation is usually typically 2 centimeters offset. Okay, so that's good. Now here I need to lengthen this line 2 centimeters. So LEN delta 0.02. Okay, and draw a line from there to the other corner, garage corner, where we have it. Okay, so that's my outline of the house. The rest of these are centerline of retaining wall, centerline pond border, stuff like that. That has been drawn on the sketch, but I always like to use the pictures. So here are the pictures of the property. Okay, just going around. So I definitely look at pictures when I'm drawing these. There's some retaining walls, there's fences. Okay, and these are the pins. These are the survey pins. So bent pin, so basically this is the top of the pin, this is the bottom of the pin. So the point in AutoCAD that says found eye top is this point, found eye hole is that point. Okay, that's another bent pin. So when I say that the eye hole, this is our best guess at eye hole. If we keep digging, this pin is probably bent. Like technically we're supposed to be digging until we find the straight portion of the pin. Okay, sometimes it's hard to do. So if I've got a shot here, I've got a shot here, I know, and the eye hole could be further down, about here somewhere. And that's what we demonstrated over here with this. So the bottom of the pin essentially is very close to being on the line between our calculated coordinate there and our eye hole for this one. Okay, I'll just draw some of the concrete work here. So we've got a back of walk, so PL polyline, so back of walk, back of walk, back of walk. Just keep going there. So what do I mean by back? So back of walk is the back edge of sidewalk as shown by the arrow right here. So I have basically created a polyline connecting all the points. Now I use this trick, so PE for polyline edit, select polyline, and it gives me all these options down here. If I hit fit, let's see how that works. So it kind of smooths everything but still using all the points. That looks pretty good actually, so I'm happy with that. So we'll leave it as that. That's the back walk. Now we have back walk at concrete, so that is going to be this point and this point basically. So let's just draw those. L for line. From there goes probably straight to the garage. Well, not necessarily. I'm gonna have a look at the pictures here. So because usually we have the walkway going around that, so let's look at the picture here. Yep, so technically he should have a shot here, but he doesn't. So we're gonna have to use the field notes to draw. Okay, so looking at the field notes, basically I've got this dimension 1.51 from the garage corner to where it starts. Okay, so let's do that. 1.51. So I'm just going to draw a circle, this corner, 1.51. I'm going to trim this line right here. Okay. Then, according to the field notes, this is 1.24 wide. So there's a sidewalk that is 1.24 wide. So let's offset this line, 1.24. Okay, and that's going to be concrete, so match properties to make that concrete. Alright, so I'm going to draw a line here, anywhere perpendicular, and then move it from there to there. Now, if I do a fillet, I can basically draw that, but that's not how it is. There's actually a radius there, and field crew should have measured the radius of this curve, but let's see if do I have a better picture. So this radius I don't have to be able to draw that, so I'm gonna have to make some assumptions. This is a better picture right here. Okay, so I don't know, I basically try different radiuses to make that work. So if we, let's say we try a radius of 0.6, about 2 feet, it ends up being like that, but seems like, just looking at the picture, a little bit bigger. So again, radius, maybe I'll use 1 meter, and yeah, I think I'm happy with that. So that's basically how that is. Let's see, what else do we have here? Just looking at the pictures, so we got some steps and all that. Let's see if we have shots or not. I don't think I have shots for the step corners. Okay, so I don't have survey points for any of this stuff here, I don't think. So I'm going to use the dimensions on the field notes. I know that this is a wood porch that's 1.83. So this from distance from here to here is 1.83. This is flush with the house. Okay, and then we got steps, which should be the same width, 1.24 wide. Each one is 0.28. So using that information, let's get going on this. So I'm going to offset this 1.83. Okay, that is my landing line. Step, what does that say? Stucco pillar. Okay, so we got a stucco pillar here, and that's okay. I'm going to trim this line here. I'm going to match properties to that. Now we got 1, 2, 3 steps. Each one is 28. So offset 0.28. 1, 2, 3, and trim all of these. Okay, so those are my steps, and I'm just going to draw this line going to this corner right there. Okay, so that is that. Then we got all these centerline retaining wall. So this retaining wall here has been surveyed, and we've got the center line of it shot. So center line of retaining wall. Let's see if I can draw that. So it seems like it starts here. So I'm just going to draw polyline. I'm just going to follow the shot. So shot 47, 48, 49, 50, 51, 52, and it probably ends right there. What else do we have here? Pavers, centerline planter, eaves, centerline planter. What planter are we talking about? Okay, there's a little planter right there. Okay, and according to the notes that I'm looking at, it's 0.2 wide. So let me just draw that little planter here. So I'm just gonna do PL planter. Seems like I've got two shots for that. Centerline planter, planter. Okay, let's do a PE and see what it does. Fit. Yeah, that's pretty good. I would probably extend it to that corner. I'm just going to look at the picture to see what happens exactly there. Looks like the outside edge of the planter is flush with the stucco there. And according to the notes, this planter is 0.2 wide. So I'm going to offset this by half of that, which is 0.1 one way, and another, and then actually get rid of the center line. So, and you know, we can just extend it a little bit like that. Trim that line. Okay. I know, I really want this to go to this one right here. Maybe that's what I'll do. So 0.2, you'll see what I'm doing here. Okay, I think that's pretty good. That's okay. All right. Now, to continue with this other retaining wall, it continues to the back, but I think I'm gonna stop now because we get the gist of it. Let's just try drawing the eaves maybe as well. So eaves, we got a shot right there, shot right there, don't have a shot right there, so I'm just gonna make it perpendicular to this. We have an eaves shot right here, make it perpendicular to that, do a fillet, radius of 0 for these two, draw a line from there, probably we got an eave shot right there, and one all the way at the back. Now I'm also checking for any other eave shots, so EL, that's an eave shot, that seems pretty close. Got some other eave shots there. They're all on that same line, and the reason we have those is because the eave has been shot at different locations. I'll show that on the pictures here real quick. Okay, so the reason that we have some eave shots here is, if you look at the pictures, you got lower eaves and upper eaves on this house. Let's go back to the front. Oh, there we go. So for example, we probably have an eave shot at this corner, and we have at this corner, and we have one at this corner, and you know, they both line up as far as distance goes to the north building line. Okay, but they're at different locations. So we just show the furthest extent of the eave. So technically he didn't need to shoot a corner for these. And I kind of look at the elevations of the points to see, you know, where it was shot. So this is 100.616 meters. This is 103.297. So this is almost like 3 meters higher than this. So I know that's the higher eave, kind of like that. Okay, that concludes this video for now. I'll upload some other ones